Hey guys, what's up? This is AJ of Bridge Code, and for this tutorial, we're going to be talking about AWS EventBridge and how we can use it as a serverless event bus to ingest events and route it to AWS Lambda functions. So, for those who aren't familiar with AWS EventBridge, it's actually a relatively new service that AWS debuted just a couple years ago, and what it is an event bus that you could use to decouple and integrate different services and other third-party SaaS providers. It helps you ingest and route events from a multitude of supported SaaS providers and other AWS services like Lambda or S3. And this is particularly useful if you're designing or implementing an event-driven microservice architecture. For example, we have an order service here, which belongs to an e-commerce system. When an order is created, it will just broadcast observable events to certain microservices that are subscribed through a set of defined rules that we configure in EventBridge. This makes everything decoupled, and basically everything is just subscribed to EventBus, waiting for certain events to be routed to them. Now, let's talk about some of the advantages of using AWS EventBridge. What's interesting about it is that it is serverless. You don't need to set up a server or spin up a server instance on the cloud to set it up on. AWS provides this event bus for you with their infrastructure. You don't need to manage anything or make very specific configurations. It will just work with your services. Another is decoupling and simplified event routing, which is really an advantage not only with EventBridge, but of any event bus mechanism, particularly if you're implementing an event-driven architecture. Now, given that EventBridge is serverless since it runs on AWS managed infrastructure, you can expect that this event bus will be highly available and downtime will be very minimal to none. And finally, perhaps the most compelling reason to use EventBridge is that not only can you source events from different AWS services, you can also use it to ingest from a variety of SaaS providers that AWS supports. And if you go to their official site, you will see a handful of SaaS providers here that EventBridge can integrate with, like Salesforce. There's also Auth0, MongoDB. We also have New Relic for tracking the performances of your apps. And there's also Shopify. Here. And really, the list just goes on. And AWS is continuously trying to establish more partnerships to have more third parties be readily integrated with their services. Some additional info about EventBridge. Besides the supported SaaS providers, EventBridge also supports more than 90 other AWS services as event source, which includes services like AWS Lambda or S3. And it also supports about 17 AWS services like SQS or Lambda as targets for events. You are charged $1 for every 1 million events put into the event bus, and there is no additional charge for the delivery of events to your targets. Now, while EventBridge could ingest from a multitude of SaaS providers, we aren't actually going to be integrating with any specific third parties. Instead, we'll just keep things very simple and just ingest and route events to and from different AWS Lambda functions, just to briefly demonstrate how you could use EventBridge. So what I'm thinking of doing is a customer support system for a food delivery app like Uber Eats or Grubhub, or if you live in Southeast Asia, GrabFood. Let's say, for example, a customer reports something about his food, like it wasn't properly cooked, or that it wasn't handled carefully during delivery, or maybe there's a problem with the app itself, like it's slow or not loading the food items. From his mobile app, it'll call a REST API, which is a Lambda function, to submit the concern or the issue that he wants to report about, and that REST API will then process this request as an event and send this event over to the event bus, which is AWS EventBridge, and EventBridge will decide which target will it route that event based on the set of rules that we will configure later. So, for example, if in our JSON request the concern type is about or related to food, EventBridge will route the event to quality support service, which is again another Lambda function, who's probably going to take some unique action about that event, or maybe send it to a support queue dedicated only to receive support requests for food, where there will also be dedicated representatives who would handle those requests or whatsoever. This is not really an actual customer support flow, and we're just making things up. And the same goes to other support requests. If it's about delivery, it gets routed to logistics support service and to tech support service if it's anything about how the app functions. Again, this is not an actual workflow of customer support for food delivery apps, and we're all just making this up to show you how we can use EventBridge. So to get started, I've already prepared the code of our Lambda functions. We have the Lambda function for quality support service, which basically does nothing except to just log that it received a new event. Generate a ticket ID, like we're going to pretend to attach this unique ID to the support request, and basically just log the event which contains the support request itself. And it's really going to be pretty much the same for the other target Lambda functions. They're not really going to be doing anything special to the events they received, except to just show that we're able to route events to them based on the rules that we configured in EventBridge. Feel free to just pause this video if you want to copy the code, but these are all uploaded on GitHub, which I have pasted the link in the description below. Onto our handler.js code, which is going to be our REST API. As you can see, currently it just logs the support request that was submitted, but we're actually going to do some more work here by processing the request as an event, and then send this event over to our event bus, which is EventBridge. To do this, we'll first need to get the AWS SDK as a dependency. But before this, I've actually initialized npm, just so you know, otherwise this won't work. If you don't feel like doing this on Node.js, you can do it in Python, you can do it in Java, or perhaps any language that AWS Lambda supports, and an AWS SDK is available for those languages as well. In our handler.js code, we need to require the AWS SDK, initialize EventBridge, let's first build the params object that will pass in later. As you can see, entries is an array, which means you can send in multiple events to EventBridge. Let's set detail to be the event body, which contains the request itself. And this is very important because this is a field that we'll refer to when we configure our rules in EventBridge later. Let's set detail type to be support, but this can be any string you want. Let's set the event bus name to be food delivery app event bus. And it's also important that you set this correctly. Later, we will also create a new event bus with the same name. I want to set the source to be this Lambda function. And the time to be just the current time. Let's add logging here to indicate that we're now sending the event to the event bus. Finally, let's call the put events function and pass in the params object we created, followed by a callback function. Let response console error. Status code, let's set this to 500, and the body to just be an error message. Send event to event bus. Else, let's come up with a message here, like new events sent to event bus, console log the message. Let's just copy and paste this here. Let's change this to 200. Pass in the message. Let's just call the callback here. Pass in the response. I believe these are all the Lambda functions that we'll need. We'll have a total of 4 Lambda functions. 1 Lambda to serve as the REST API, which is our event source, and 3 other Lambda functions that serve as targets for the events. Now, you should know that we will be using the serverless framework to easily deploy these Lambda functions to AWS. That's why I have this serverless YAML file here. But using serverless is not required to follow along with this tutorial, and it has nothing to do with AWS EventBridge. In case you want to know how you can deploy to AWS with serverless framework, I've also created a tutorial for that, which you can find in this channel. But again, serverless is not required to deploy your Lambda functions and is not related in any way to EventBridge. This is just a matter of personal preference to deploy my Lambda functions. You can easily just go to AWS console and under Lambda, just write your function code in the provided code editor there. For our Lambda function that sends events to EventBridge, you also need to ensure that it has the right permissions to do so. I believe these are just the minimal permissions you need to send events to EventBridge. You probably don't need describe event bus, but I just added it here just in case. So now let's deploy our Lambda function to AWS. So now it's finished. You can see that an API endpoint was also generated for us with the help of serverless. And if we head over to our AWS console, under Lambda, you will see that 4 Lambda functions were deployed. And now it's time for us to create a new event bus in EventBridge. To your left-hand side, click Event Buses. Click Create Event Bus. We're just gonna copy and paste. This event bus name we specified in our code, which is Food Delivery App Event Bus. You may choose to add a resource-based policy to specify who gets access to your event bus, but we're just going to leave that blank. And let's hit create. As you can see, we now created a new event bus. We also could have just made use of the default event bus that was already created by AWS for us, but creating a new one is better. Next is we will create our rules. Again, to your left hand side, click rules and click create rule. We have to create 3 rules. The first rule is for routing requests with a type of food to our quality support service, which is again the Lambda function we deployed. The second rule is for routing requests with a type of delivery to logistics support service. And the third rule is for routing requests with a type of app to tech support service. Let's name this rule to be support requests for food. Description is optional. When defining a pattern, we can either set a schedule to trigger this rule regularly on a schedule you specified. It can either be fixed for like every minutes, hours, or days, or a cron expression. Or we could also just select the event pattern, which is what we will do, to specify a rule depending on the type specified in the JSON request. So let's choose custom pattern, and let's type the pattern. Should be detail. Type food. So what this pattern tells us is that under detail field, which as you recall earlier is included in the params object we defined and set it with the event body containing the JSON request itself. The type should be any value included in this array list or array, which, as you can see, we just specify the word food, indicating that the value of type in the request should only be food for this rule to take effect. Let's go ahead and save this, and I'll just copy this pattern for later. Let's select the event bus, which is the one we just created, which is Food Delivery App Event Bus, and not the default AWS Event Bus. The target should be a Lambda function because we want to route events over to the Lambda functions we created earlier. And to be more specific, we want support requests with type of food to be handed over to quality support service for processing. Tags are optional, and let's click create. And as you can see, we now have a new rule for any incoming customer support requests with type with regards to the food they ordered. And this is pretty much how we're going to create the rest of the rules for support requests with type of delivery and app. And I'll just create those rules quickly. So we've now deployed all our Lambda functions to AWS, created a new event bus in EventBridge, and created all the rules we need to route events to the different Lambda functions, also in EventBridge. I believe we are now ready to test our work. We are now in Postman, and I've pasted the API endpoint we got from when we deployed our Lambda functions with serverless. I'm gonna submit a support request about the food I just ordered. Type will be food, and let's have the report to be the chicken was not properly cooked. We're going to submit this report. As you can see, it says that we were able to send an event to our event bus. Let's first go to CloudWatch. Let's go to CloudWatch where our logging takes place. And let's check if the logging for our REST API actually worked. So that's in customer support. So as you can see, it first logged that a new customer support request was received. It logged the request itself, and this is the point where it's attempting to send the event to our event bus, and this is the confirmation that the event was sent over to the event bus without any errors. Now, if we check the logs for customer support service, where we're expecting the event to get routed, as you can see, it was able to receive that event. We generated a fake ticket ID here, and we logged the event we received containing the JSON request in the detail field. Let's go back to Postman, and this time we're going to report an issue with delivery. Let's say the delivery rider spilled the drinks. Let's submit this, and that there's also something wrong with the app. loading food images. Let's submit this too. And if we go to CloudWatch logs and see the logins for logistics support service, you can see that everything was logged the same way how things got logged from the customer quality support service. And here is the JSON event that was routed to this Lambda function because the type is delivery. And if we also go to the CloudWatch logs of tax support service, you can also see here the JSON event that was routed to this Lambda function because the type is app. So that's it for this tutorial. I hope AWS EventBridge made sense to you. If not, feel free to drop your questions in the comment section and I'll try to answer them. Don't forget to hit like and subscribe, and thanks for watching. Bye.